Imagine for a second that the Earth isn't just, a giant rock floating through space,
Mm,
but an enormous spinning magnet.
right.
Now imagine if, just by sitting exactly where you are right now, you could somehow plug a wire into that planetary rotation and generate electricity.
Oh, wow.
Yeah, not from wind, not from solar, but from the raw rotational energy of the planet itself.
I mean, that sounds
I know you're probably having the exact same alarm bells going off in your head that I am right now.
it sounds like a perpetual motion machine, right? Something that breaks every rule in the physics playbook.
It really does. It sounds completely impossible.
But you are about to hear how a fascinating 2026 physics paper published in Physical Review Research is defending a very real physical device that sits on a lab bench and does exactly what we just described.
Yeah, and this is why this deep dive is so exciting.
Right.
We are looking at a classic high-stakes showdown between physical experiment and theoretical modeling.
A real academic standoff. Exactly. This paper is a formal reply written by Christopher F. Chiba, Kevin P. Hand, and Thomas H. Chiba. And they are fiercely defending their device against a theoretical critic. A critic who insists, mathematically, that their machine violates the laws of physics and must produce absolute zero power.
Okay, let's unpack this.
Mm.
Because to understand why this has caused such a stir in the physics community, we first need to look at what these researchers actually built, right?
Right, the physical device.
So back in 2016, they proposed the underlying theory. But by 2025, they moved from the whiteboard to the workbench and actually constructed the thing.
They built a physical prototype.
Yeah, they built a hollow cylindrical shell out of a specific material called manganese zinc ferrite.
Which is a classic soft magnetic material.
The soft meaning what exactly?
Meaning its magnetic domains align very quickly with an external magnetic field, but it doesn't retain that magnetization once the external field is removed or if it changes. It's highly permeable,
Like-
so it allows magnetic flux to pass through it very, very easily.
So they took this hollow cylinder of soft magnetic material and they rotated it within the Earth's natural background magnetic field.
Right, just ambient Earth magnetism.
And according to their 2025 paper, they successfully generated a continuous direct current voltage. They extracted around 10 microvolts.
Which, I mean, is tiny.
Oh, for sure. Obviously, 10 microvolts isn't going to charge your phone, but the magnitude really isn't the point here.
Exactly. The fact that it exists at all is the breakthrough. It proves a massive concept.
And they didn't just run this once in a messy lab and call it a day. They physically moved their entire experimental setup 5.5 kilometers away from their primary lab.
Wait, really? 5.5 kilometers?
Yeah, just to prove this wasn't some localized anomaly like, weird stray magnetic fields from the wiring in their building's walls.
That is dedication. And they were also incredibly rigorous about controlling for confounding factors, too.
Oh, absolutely.
Because when you're measuring a voltage that's, 10 microvolts, even the ambient temperature of the room can trick your instruments.
Right, like temperature fluctuations.
Yeah, so they continuously monitored for thermoelectric voltages, specifically the Seebeck effect.
Remind me, that's when temperature creates a current.
Right, it's where a slight temperature gradient across a conductive material can generate its own tiny voltage. And they conclusively ruled all of those artifacts out. The 10 microvolts was completely real.
So you'd think a physical device generating measurable, heavily controlled voltage would be case closed.
You would think so.
But there's a physicist named Weingarten who published a formal comment attacking their original 2016 theory.
Right, the critic.
He goes through the complex math of relativity and electromagnetism to conclude that the electromotive force, the generated voltage, must, under all circumstances, equal zero.
That it just can't work.
But wait, I have to push back on this on behalf of anyone listening, because if you're tracking with us, you've got to be wondering, how on earth is this critic mathematically proving it's impossible when the physical device is literally sitting right there on the lab bench generating voltage?
It's a good, quick question.
Like, did he just ignore the physical device? What is his equation seeing that reality isn't?
Well, what's fascinating here is the philosophical stance the critic takes on the nature of empirical science itself.
How so?
Weingarten actually immunized his theoretical argument against physical evidence.
Immunized it.
Yeah, he explicitly stated in his critique that even if future experiments prove the device works and extracts energy, his theoretical objections will still hold.
Wait, seriously? So he is essentially arguing that if his math says it shouldn't work, then a physical device that appears to work must just be hiding some other effect.
Or that their interpretation of the experiment is fundamentally wrong. Precisely. He wrote that new experiments cannot be used by themselves as a refutation of his mathematical objections.
That is wild.
It really sets up a profound debate about the hierarchy of knowledge, right? Like when mathematical theory and physical experiment clash, which one gets the final word?
That is just, don't bother me with your physical evidence, my math is flawless. So, since the critic absolutely refuses to accept the physical device as proof, the authors realized they couldn't just point to their flashing voltmeter.
No, that wouldn't work for him.
They had to beat him on his own turf. They had to win the theoretical battle.
And that theoretical battle comes down to a highly specific, very nuanced argument about how magnetic fields actually move through matter.
Right.
It really boils down to two competing concepts: advection versus diffusion.
Okay, advection versus diffusion. Let's break that down.
Let's look at Weingarten's model first. He claims that as this magnetic tube rotates, its own magnetic field, what he refers to as the tube's field, translates perfectly with the moving cylinder.
So the tube and the field move exactly together.
Exactly. Imagine the cylinder and its magnetic field are completely locked together. And well, because of relativistic field transformations, if the field moves perfectly in tandem with the object, the electric field caused by that motion perfectly cancels out the effect.
Which means no current?
Right. It means the current density, which is represented by the letter J in these equations, equals 0. And if current density is 0, the power generated is 0.
But the authors point out a massive hidden assumption in his critique, don't they?
A huge one.
Weingarten's math only works if you are dealing with a system that has a very high magnetic Reynolds number.
Right.
Let me define that for you real quick, just so we're all on the same page. The magnetic Reynolds number, or prime, is a dimensionless ratio used in magnetohydrodynamics.
That's a mouthful.
It really is. But it basically compares the rate at which a magnetic field is advected or carried along by a moving material versus the rate at which the magnetic field diffuses or slips through that material.
Yeah, so in systems with a high magnetic Reynolds number, advection dominates. The field rigidly moves along with the object, just as Weingarten described.
But the authors deliberately built a system with a very low magnetic Reynolds number.
Exactly.
So let me try an analogy here to visualize this, because it's tricky. Weingarten is picturing this magnetic field like a framed painting, right?
Okay, a painting.
Yeah, so if I pick up a framed painting and walk across the room, the image just moves as one solid, rigid piece. That's advection.
Right, it doesn't change.
But because this manganese zinc ferrite has a low magnetic Reynolds number, the authors are saying it's actually more like moving a digital screen, like a tablet.
Oh, that's a great way to put it.
Yeah, as you walk across the room with the tablet displaying a map, the pixels, the magnetic field lines in this case, they have to constantly update and redraw themselves based on where they are in relation to the Earth's background field.
They're continuously shifting.
Right. That tiny lag, that constant redrawing process inside the material, that is magnetic diffusion.
And because of that constant redrawing, the diffusion, the magnetic field does not perfectly translate with the moving shell.
It's not a rigid painting.
No, there is a microscopic slip, a lag. And because the field isn't moving rigidly with the cylinder, those relativistic electric fields do not perfectly cancel out.
Which changes everything for the math.
It changes everything. Therefore, the current density, J, is not 0. Power is generated.
So the critic just assumed diffusion was negligible.
He did, which, mathematically works for a framed painting, but completely falls apart when you bring an iPad into the equation.
Right.
The authors mathematically proved that for a low magnetic Reynolds number, you just cannot ignore that diffusion term. If you plug the diffusion math back in, the critic's own equations suddenly predict the exact same 10 microvolt voltage the authors measured in the lab.
Wow. They used his own math against him.
They did.
But this raises a mechanical question for me. Why does the field have to, redraw itself in the first place?
What do you mean?
Well, I mean, if you just spin a uniform chunk of magnetic material in a uniform background field like the Earth's, you'd think the field inside the material would just stay uniform, right?
Oh, I see. Well, that brings us to the actual physical topology of the device.
Sure.
Because they didn't just spin a solid block of ferrite.
Right, they spun a hollow tube.
Exactly.
Here's where it gets really interesting.
So let's consider a solid rod first. If you take a solid cylinder of soft magnetic material and place it in the Earth's magnetic field, the field lines inside that solid rod become completely uniform.
They just pass straight through.
Yeah, they straighten out and run completely parallel to each other. So if you are a specific point inside that solid rod as it moves, you look around and the magnetic field never changes its magnitude or relative direction. It's perfectly constant.
And because the field never changes from the perspective of that point inside the rod, there is no need for the field to redraw itself.
Right.
There's no diffusion. It's just pure advection.
Exactly. And in that scenario, the authors actually completely agree with the critic.
Wait, they agree?
Yeah. They agree that a solid rod generates absolutely zero electromotive force.
Huh. But the authors specifically drilled out the center of their cylinders.
They did. And by making it a hollow shell, they introduced a powerful phenomenon called field channeling.
Field channeling.
Yeah. When you have a hollow shell, the magnetic field lines from the Earth prefer to travel through the highly permeable ferrite rather than the empty air in the center. The material acts almost like a magnetic funnel.
Okay, so the empty space literally forces the magnetic flux lines to crowd together. They sort of curve and distort as they squeeze through the thin walls of the cylinder.
Because they're actively avoiding the hollow center.
Right.
And this is the crucial insight for the entire debate. Because the magnetic field inside the shell wall is heavily distorted and bunched up, it is highly non-uniform.
Okay.
So as the cylinder rotates, any fixed geometric point inside that ferrite wall is constantly sweeping through varying strengths and varying angles of the magnetic field.
Oh, I get it. So at 1 millisecond, a point in the wall is in a really dense cluster of curved field lines.
Yes.
And then a millisecond later, as the cylinder turns, it's in a less dense area.
Exactly. The field at that point must change.
And because it's constantly changing, it forces that magnetic diffusion, that pixel redrawing we talked about, to occur in real time.
You've got it. That changing field forces the diffusion, and the diffusion is exactly what generates the electricity.
Wow, so the critic basically solved the complex math for a solid stick.
He did.
But these guys built a hollow tube.
Yeah.
The empty space, the drilled out center, is literally the geometric secret that makes the physics work.
It is. Without the hollow center, the field doesn't distort. Without the distortion, there's no diffusion. And without diffusion, no electricity.
That is brilliant. Okay, so the math works out when you include diffusion, the geometry works because of field channeling, and the physical experiment generated actual verified voltage.
All confirmed?
But we still have an elephant in the room here.
Oh.
I mean, we are taught from day one,
Mm-hmm.
you can't get something for nothing. Energy cannot be created or destroyed.
The thermodynamics of it all.
Yeah, if you were generating electricity just by sitting a tube on a table and letting the Earth's rotation do the work, where is the energy actually coming from? What is the fuel?
It's a great question. And if we connect this to the bigger picture, this is a beautiful example of how physics resolves its own apparent paradoxes.
How so?
Well, the critics of this device, including Weingarten, often point to a foundational concept called the flux rule to say this shouldn't work. This whole academic standoff is actually deeply reminiscent of one of the most famous historical problems in electromagnetism, the Faraday disk paradox.
Oh, Michael Faraday, the 19th century pioneer of electromagnetism.
The very same. So back in 1831, Faraday built a device where a solid conductive copper disc spins between the poles of a horseshoe magnet.
Okay, 1831, so this is an old problem.
Almost 200 years old. And when he brushed contacts against the center and the edge of the spinning disc, it generated a constant direct current. It was literally the world's first electrical generator.
Wow.
But for decades, it completely broke the theoretical math.
Wait, how does a working generator break the math?
Well, it was because of how the standard flux rule is calculated. The rule states that voltage is generated by a change in magnetic flux through a closed circuit loop.
Right.
But if you try to calculate the changing magnetic flux by drawing a single, simple radial line from the center of Faraday's disk to the outer edge, that line just sweeps through a uniform magnetic field.
It doesn't change.
Exactly. The flux passing through that single imaginary line never changes. So, according to the standard single-path equation, the voltage should be zero.
But it wasn't.
It wasn't. It looks like it shouldn't work on paper, yet physical reality proves it does.
So the math was fundamentally misinterpreting the physical reality of the object.
It was wildly oversimplifying it. It took physicists a long time to realize that you can't just draw a single 1D line on a 3D object.
Oh, I see.
In a solid spinning disk, the current paths aren't a simple, isolated wire loop. They're distributed throughout the entire metal.
It's the whole volume.
Exactly. To get the math to match reality, you have to abandon the single path method and integrate the Lorentz force over the entire 3D volume of the disk. When you do that volume averaging, the math perfectly predicts the experimental voltage.
And the authors of our 2026 paper realized the exact same mathematical trap was being used against them.
They did. Weingarten was essentially using single-path logic. The authors used a rigorous volume averaging approach for their hollow cylinder,
Right. They integrated the equations over the entire highly permeable shell.
which proved the math is fundamentally sound. But to answer your million-dollar question, where does the energy actually come from, we have to look at the physical consequence of that volume integration.
Okay.
When this hollow cylinder rotates and generates that 10 microvolt current, something else happens. According to Lenz's law, an induced electric current will always create its own tiny secondary magnetic field.
And that secondary magnetic field has a specific orientation, right?
It does.
It's going to push back against the change that created it, meaning it pushes back against the Earth's background magnetic field.
That is the exact mechanism. It's a phenomenon called magnetic braking.
Magnetic braking.
Yes. The power you are extracting to generate those 10 microvolt isn't coming from nowhere. It is coming directly from the Earth's rotational kinetic energy.
Wow.
By generating that tiny amount of current, the secondary magnetic field of this small cylinder sitting on a lab bench is mechanically dragging against the Earth's magnetic dynamo. It is imperceptibly pushing back against the entire planet.
So what does this all mean? If the energy isn't coming from nowhere, and the secondary field is pushing against the Earth's background field, we are literally using the planet's kinetic energy as a battery.
We are.
Every time that machine runs, we are just spinning the Earth.
The Earth's rotation slows down by an unimaginably small fraction to balance the energy equation. The kinetic energy of a spinning planet is the fuel.
That is just staggering to think about. I mean, obviously, we aren't going to stop the Earth's rotation anytime soon with 10 microvolts.
No, definitely not.
But just proving this effect is real, proving that we can tap into the planetary spin and extract measurable power, is a monumental step for physics.
It is, and the authors are eager to see this pushed further. In their conclusion, they issue a strong call to action.
What do they want to happen next?
They want other independent labs to reproduce this experiment and confirm the volume averaged math.
But reproducing this is going to be a nightmare for other labs, isn't it?
It really is.
Because the authors specifically noted how wildly the properties of manganese zinc ferrite vary between production runs. You could buy the exact same product name from the exact same manufacturer, and the electrical conductivity and magnetic permeability could be completely different.
It is a massive engineering hurdle. You're completely right. Furthermore, most commercial manufacturers don't make long, hollow cylinders out of ferrite. They make small rings for basic electronics.
Yeah, and you can't just stack small rings together to build a tube.
No, you can't.
Because the microscopic gaps between the rings would change the conductivity and let the magnetic field leak in, right?
Yeah.
It would ruin the field channeling effect entirely. You need a continuous monolithic shell.
Exactly. You need one solid piece. But they do offer a blueprint for how to scale the power output if a lab can crack that manufacturing problem.
How so?
They point out that the generated voltage is highly dependent on the ratio between the inner radius and the outer radius of the tube.
Okay.
The cylinders in their 2025 experiment were made by physically drilling out the center of solid blocks.
Which severely limits how thin you can make the walls before the material just shatters.
Exactly. But if a lab could manufacture a much thinner hollow shell from scratch, bringing the inner wall much closer to the outer wall, they theorized you could scale the power up to around 100 microvolts.
In order of magnitude larger.
Yes.
100 microvolts is still tiny in the grand scheme of things, but it makes the signal much more robust.
Absolutely.
It makes it undeniably clear, much harder for theoretical critics to dismiss as background noise or, diffusion errors.
Exactly. It's about undeniable proof.
This whole story is such a perfect reminder of what science actually is. It isn't just neat equations on a pristine whiteboard where everything balances perfectly. It's the messy, difficult, and triumphant process of building physical things in the real world.
It's getting your hands dirty.
Yeah. Things that sometimes break the elegant equations and force our mathematical models to evolve and catch up to the reality sitting right in front of us.
It's beautifully said. This raises an important question, though, and it's something the authors touch on briefly that I think is truly profound for you to consider as we wrap up.
No way. What's that?
Well, we established that the energy comes from magnetic braking, from literally slowing the Earth down.
Right. to spinning the planet.
But the authors note that the magnitude of the generated current is intrinsically tied to the speed of Earth's rotation.
Okay.
Over an incredibly long period of time, as the Earth despins from this magnetic braking, the planet's overall magnetic field magnitude would actually begin to decrease.
Wait, really? The planetary field itself would weaken as the dynamo slows.
Yes. So imagine a science fiction future for a moment. Imagine humanity eventually decides to scale this technology up massively.
Okay.
What if we build giant, city-sized hollow cylinders of ferrite scattered all across the globe, powering entire metropolitan grids directly from the kinetic energy of the planet's rotation?
Wow. We would be pulling immense amounts of kinetic energy out of the spin,
Yeah.
drastically accelerating that magnetic braking.
Exactly. So if our insatiable thirst for energy led us to use the Earth as a giant homopolar generator, would we eventually alter the length of a day on Earth in a human time frame?
That's
Would we reach a point where humanity has to literally budget our planetary spin as a finite natural resource?
a daily energy allowance. Otherwise, the sun sets an hour late and we lose our planetary magnetic shield.
It's entirely possible.
That is incredible. Brings us right back to where we started. We're sitting on a giant spinning magnet. And while we might only be pulling 10 microvolts out of it today, we've essentially figured out where the plug goes.
We just have to decide how much we want to turn the dial.